This time we're going to talk about cosine. Remember, the cosine originates at 0, 1. Please hearken back to the unit circle, and that'll help you visualize it. But the periodicity of a curve, if it's just cosine x, then the period is 360 degrees. So remember, go from peak to peak. And this is in radians. I can't for the life of me figure out how to get Desmos into degrees. I tried. But it's okay, because we understand radians now. So 360 is going to be 6.28, 2 pi, right? So peak to peak. Now if I change this, if I change the x to 2, then it's going to go twice as fast. So notice from peak to peak this time, it goes to pi. So instead of 2 pi, the waves are half as long. In other words, the periodicity, the periods are half as long. And what if I put 4 pi? What do you think is going to happen? You probably already know. So 360 divided by 4, and it's going to be every 90 degrees then. Okay, and that's a cosine of 4x. Cosine 4x. And that's what your curve is going to look like. So like I said before, if it's a cosine of 2x, that's going to double the period length. So the sine wave is going to go twice as fast. But what I encourage you to do is think about it this way. Substitute theta in for 2x, and then we can handle the rest of it later. So theta is equal to 2x, and we'll substitute it in later. So back to the problem, we want to find 3 cosine 2x is equal to 2. We're trying to find all the values between 0 and 180 degrees. And as you can see, we're going to have multiple values, but we just have to go between 0 and 180. But we're trying to find out, see, this is y is equal to 2/3. I went a little bit ahead of you, a little bit ahead of where you might be at this point. But cosine of 2x. So now every value is going to be at pi, or every 180 degrees is going to go through this horizontal line. So if you look at this in Desmos, we just have 2 values between 0 and 180. We just have it here, and we have it here. 3.14 is pi, and the problem didn't ask us to go greater than 180. So I'm going to come back to the beginning and remind you that every time you go from peak to peak, in this case from here to here, and I change it to cosine of x, it's 360. All right, but we've got a different situation now. It's 2x. So that means it's going twice as fast. Now back to our problem. I found the inverse cosine, or the arc cosine, of 2/3, and I got 48.2. And then let's just say this were the cosine of x. It is cosine of 2x, but I'm going to clarify, well, maybe not clarify, but I'm going to teach you how to solve it. Hopefully. But we've got 48.2, and we've got 360 minus 48.2. So if this were cosine of x, you would subtract it from 360. Okay, now we're going to get to the substitution part. And this is where it gets exciting. So we're going to put 2x in for theta, and we're going to solve each of these. And we're going to find this out, where the solutions exist between these 2 increments. So we substituted 2x in for theta. I can't remember if I already said that. I'm trying to hurry this up because I've got a meeting in a minute. But now we've got to solve for x. No problem, divide by 2. And we have the solution. The solutions, rather.